In this video, we're going to explore unit rate and inversely proportional relationships. Now, when we're talking about unit rate, what we're going to do is take our ratio and divide everything by that second quantity, so we have a fraction of the first quantity for 1 unit of the second quantity. So if I look at this, I have 3 teaspoons of salt for 4 teaspoons of pepper. That's a lot of salt and pepper, and I may not need that large of a ratio. So instead, I can divide both terms by 4, because I've got my ratio of 3 to 4, and that's going to change my first quantity to 3/4. So now I have 3/4 a teaspoon of salt for every 1 teaspoon of pepper, and that may be more relevant if I'm cooking. When I look at, say maybe I'm trying to make paint, and it takes 5 cups of yellow for every 2 cups of blue. Maybe I don't have a container that will hold 7 cups. So if I divide both terms by 2, I would end up saying that I have 5/2 cups of yellow, or 2.5 cups of yellow, for every 1 cup of blue, and maybe that could be held. Now, also we have this notion of cross multiplication, and we've done this quite a bit, where you cross multiply and then divide by the term that's with our variable. So in this case, I would say 7 times 8, and then 5 times a, and then I divide by the 5. Why do I do this? Well, you have to remember what's the definition of a proportion, and it's that I have 2 equivalent ratios. Now the thing is, the way they're written, it's very difficult to understand that they're equivalent. But what I could do to understand that is to create common denominators. And if I think about having 5 and 7, my common denominator would be 35. Now I'd want to change both of my fractions to have a common denominator of 35. So I'd multiply 8/5 by 7. And then I'd want to multiply a over 7 by 5. Now let's see if when I set that up, that'd be 8 times 7 equals, or over 35 equals a times 5 over 35. My denominators are the same, which if I'm having equal values means my numerators have to be the same. So if I look at those two numerators, 8 times 7 equals a times 5, that's the same thing as when I cross multiply. We're just not necessarily writing out these steps right here. Now, one last thing to talk about is this notion of inversely proportional relationships. And we're talking about this in where the first quantity in our relationship is multiplied by a number, while the second quantity is divided by that exact same number. Now, this happens a lot of times when we think about man work, or work that we do as people, where the more people we have doing a job, the less time it should take, less man hours to be able to get that job done. So say I'm thinking about trying to fill a truck, and I've got 2 people, I can do it in 12 hours. If I get 6 people to help me, that means if I look at this, I've got 3 times as many people helping me out. And say that we're able to work similarly, so that by tripling my work, or tripling my people, I should be able to effectively cut my time in a third, or divide by 3. So if I look at this in a table to help out, I have 2 people, it takes 12 hours. So if I take 6 people, in this case I'd be multiplying by 3. So the inverse relationship would tell me to divide 12 by 3, and I should be able to do it then in 4 hours. I triple my number of people working, so I cut my work in a third.